I wanted to mention for Dr. Corey, that was a great presentation. I thought that you covered a lot of the topics very well, so there really weren't any questions. But I think it's really important to really keep a pulse on that ethical side of the business, and I think you did a good job of presenting that. The other thing I want to kind of clear up too, to make sure that I'm not misrepresenting anything, is that I am not a doctor, not like the people on this call. In fact, I'm not. I have a bachelor's degree, and it's in fine art. So I have no science background whatsoever. I am not a professor. I'm not in academics in any way, shape, or form. However, I've accomplished something that's quite wonderful, and I'm going to tell you about that and give you a little background into how I did this. So what I've done and how I'm going to be presenting this is through some kind of advanced calculations and some different technical stacks that I built as an entrepreneur. I was able to calculate or come to derive the unified equation of quantum field theory and fractal theory. So what this does is this takes, I call it the MEQ, and on your screen you can see that is the simplified form of the equation. There are many modifications to this, which I have done, and I'm going to go through that as well. But I just kind of how I'm starting this out when I say MEQ, that's what I'm talking about is it's the unified equation basically of physics. We'll take it a step further, and I'll actually join it with general relativity. I'll show you how to do that. So we have a unified equation of quantum theory and general relativity. And I'll take it another step forward to an actual Langerian theory of everything. So I've got quite a bit to go over here, and I will take questions as I can later on, but I just want to make sure everybody knows I've presented to CEOs, to CFOs, to all kinds of corporate types of entities, but I'd say that this opportunity with the Global Scientific Guild, it gives me the most brain power I think I've ever been able to present to. So I'm very excited about these ideas, and I really do look forward to the geniuses that are really on this call for their feedback at some point in time. So let's get started here with the flow chart of what this is. So the first thing I've done is we're going to talk about the components of the equation, how we calculate psi, and this is quantum field theory, and these are the coordinates. And then we're gonna add this fractal element. The important parts here are the D and the S. This adds a dimensional aspect to it, which is the fractal geometry part, and this has a scaling factor. That's really the key to a lot of this, and I'll explain why. We're going to combine them. We're going to obtain the wave function. So basically what I've done is I will start with the wave function, which is basic. This is the Schrodinger equation. That's a widely accepted scientific observation that we see wave activity at that levels, and we're going to end at this. So we're going to go a full circle all the way through to the cosmic, all the way back to the middle of the subatomic. So we have a closed feedback loop. These are the components. The first component here, like I talked about, is the psi QFT. This is the solution of the free quantum field theory. Over here is the fractal element when I talked about the D and the S. This is where it captures, again, the influence of the self-similar fractal patterns, which you see in nature, coastline, snowflakes, all those other things. So what I'm doing is I'm applying that to space-time, saying that because I see it in nature, it likely exists in space-time as well, and it does. And then this last component is the overall wave function. So that's really the components of the simplified equation. So how we calculate it is we're going to go through the mathematical operations, and then there's a flow here as well. I'll share this with you later. I don't want to read through all of it, but we start again with the wave function, and then there's some different calculations, some things that we'll do in the process that includes, say, the Green's function. There'll be a Laplace transform that takes place, and there's also the convolution theorem that all go into this. Again, here we go through, we're going to calculate this term. This is the fractal term. This will show you again how we go through and we apply the different mathematics to it to attain that term. Then what we're going to do here is we're going to combine the quantum field and the fractal field. So this is the full cosmic that we're talking about, and that will equate to obtaining the wave function. So we have the wave function equating to a cosmic fractal particle theory, which is very useful. And I'll kind of show you kind of why that is. It's important because this is new. This has not ever been done before, combining these two ideas. It does create a very comprehensive approach. And I think what I've done is I've gotten good, or talking about what it really does, is the way I found this is that it creates a fractal field that you can measure the deformation of. So instead of dealing with probability, which we have probability because of the nature of the quantum mechanics, instead of looking for where that particle is, we are actually going to measure the deformation of the space, which gives you a precise location in space-time of where that would be. There's also a thing called the uncertainty principle. That's Heisenberg's uncertainty principle, where at any given point in time, it may be in existence or it may not. What this equation is a tool. It's really all it is, but it's a tool that measures the perturbations in the fractal field, the quantum fractal field. So what that'll do is that will then regulate the uncertainty principle. When you can measure a thing, you can regulate a thing, which will then give us quite a bit of insights into how that works as well too. So by being able to isolate precisely within almost an infinite realm of quantum space, where that location is, we create a bit, an on and an off, and we create an encryption, we create a whole quantum communication system, which will then lead to faster than light technology, which I'll talk about later. So how this works as far as with the enrichment, we're going to go from the micro to the macro realms. This is important. We've been looking for this. Scientists have been looking at this for a long time. I happened upon this while trying to do some things for marketing, but it is what it is. And I was smart enough to figure out what it was and understand how it worked, and then to patent it. So that's been my main focus. I'm not really, this is really the first time I'm presenting this, I'd say, officially to the academic world, which makes it kind of strange. How can someone claim to say they've found the unified equation of physics when it hasn't gone through that process of rigor? A lot of that has to do with the AI validations using languages like Wolfram language, Wolfram Alpha. Some of those types of validation processes showed me that the math is correct. And because I'm not a scientist, I'm an entrepreneur, I'm going straight to market with it. And this is kind of how this works in a nutshell as far as the informed feedback loop. But where I've taken this is now actually over here. This is what we're doing with it, the so what. I think when they found what EMC squared, it took them like 10 years to figure that out, what to do with it. And the first thing they did was make bombs, basically. I patented this so that doesn't happen with this, because this equation also has that potential as well. So I'm trying to figure out a way to make sure that it's being used at least in ways that we can control. But how this works is, I'm calling it the unified equation. What it does is my company, we try to, basically our mission is to make a transformative impact on all kinds of industries by using this very, very sophisticated level of measurement, and to really unlock the potential of the MEQ. It does have fractal geometry integration. This is really the big change, is that we're actually combining fractal theory and quantum theory, which creates this macro feedback loop. There's adaptive learning and optimization that comes with it, because it does the cosmic informs the quantum, and the quantum informs the cosmic. There is this feedback loop, and we see this. We know this exists in science. We just have not been able to explain it before. We see it in our lives. We see it in all kinds of ways. But this equation literally proves that everything is all within one plenum of energy. We're all it. That the Big Bang didn't happen it's a long time ago, far away. It's happening right now. We are it. We are, in fact, the Big Bang happening today, and it's going on, long process. So how we explain that, the only thing that separates us is our beliefs, and this can be proven now with this equation. We can show that everything is interconnected. So there are some societal changes that will happen with this as well too, once people start to realize that beliefs are something that can be adapted and changed and are not necessarily something that we have to have rule our lives. In any case, where I'm going back with this is to kind of talk about what we can do with it. So for healthcare, where we're talking about that is in the drug development. We can get down to quantum level manipulations where we can change magnetic properties of molecules. We can do a lot of different things now we've never been able to do. I've mapped out a whole 15 steps to figuring out how to cure cancer and some of the other ones. There are some diseases that have fractal type metastasis, like cancer is one of them, for example. It exhibits fractal properties when it grows, and what we can do with the equation is observe that and figure out what's causing that and stop that metastasis, stop that fractal process, which is inherently would stop the spread of cancers that exhibit a fractal metastasis, which is almost all of them. So I think there's some really interesting things that can happen from this. The problem is that because it's not coming, well, it's not a problem. It's just that because it's coming from an entrepreneur rather than a professor, it's, it doesn't sink in quite as well. Education, this is again, I'm kind of mirroring some of what Corey was talking about, how it's going to change. We're going to have personalized virtual reality type experiences for people. There's still going to be the need for social elements, but the curriculum optimization, I mean, this is something where AI and also this type of looking at the macro and the informed closed loop situation is really going to help quite a bit with education and how it does change and transform. It's not obsolete. Some people seem to think that AI is going to make it obsolete. I don't believe that. Precision farming, that's another big area where we can get into with the pest control, fertilizers, all kinds of chemical applications that this equation will then again give researchers and chemists and physicists basically another infinite level of ways to measure. Climate change adaptation, we can do some quantum level monitoring of climate change. Really a big thing about this is where this is going to hit first is in quantum computing, because this equation will advance the abilities of that quite a bit. It also will then help with AI too, but those two things put together are then going to lead to quite a few more advancements in quantum sensing and simulation. So what my company is doing is we're building a platform called Quantum Simulate Plus. A lot of organizations and whether they be academic or not, don't have access to the types of tools and colliders and all those other types of things that you would need to really do quantum studies. However, the equation and some modifications to it as well has been developed into an algorithm that we can then put into a cloud-based platform that any researcher in the world anywhere can apply these ideas and these frameworks, the quantum fractal framework, to the work that they're doing, and it applies to quite a bit. Energy is a big one. These are some just different ideas that we had as far as big, large solar systems. What we can do is we'll be able to manipulate materials with this, like I said, by adjusting some of the magnetic properties and those other types of things, to where we'll be able to store energy much longer. We're going to need to do this for longer term travel. We're also going to need to generate massive amounts of energy, and in order to realize some of these technologies in the future. And there's some ways that go along with that. I'll talk about that later. Again, transportation grids. These are all different areas where we've mapped out algorithms and ways that we can work with the design performance. So for automotive industry, there's a lot of different types of ways that this can be applied. Manufacturing, again, the military is interested. The Navy, there's some really, really brilliant engineers that work for the Navy. One, Salvatore Pays, I think is his name, who's very, very close to quantum, to like fractal propulsion drives and those kind of things. So that'll be interesting to see what they're going to want to do with the development of aerospace and different types of materials that can withstand different things. We can also build fractal propulsion drives. Finance is another area that we can get into. It does, again, a very comprehensive look at any complex system where it can look at all kinds of macro and micro changes. So this combined with AI will completely revolutionize finance and risk management, insurance. Environmental, that's another big area too. Again, I talked about this climate modeling prediction. The simulation capabilities of this equation and of this framework are incredible because of the geometry aspect of it. So we can do a lot of pollution detection. We can do a lot of ideas, or we can see what's happening with the planet. I think NVIDIA is creating Earth.2. That this could be applied on top of that for a quantum level look at things. So really interesting ideas that could come out of there. Telecom, this is where and this might sound a little far out, but what this equation does, and I can show this in another time later, but it will actually, it can be used to stabilize a wormhole. And once wormholes are proven to exist, because they can, in theory, exist at any time or place in space-time, their ability to create micro wormholes. The wormholes don't have to be the science fiction type of thing where they're this big, massive thing out in space. It can be a quanta-sized wormhole. And through those wormholes, you can, by studying the perturbations of it, you can then figure out the energy requirements to stabilize it. And when it's stable, you're able to, an electron can pass through, in theory. So the idea would be then is we have instantaneous communication. That's how you get to, that's what faster than light is it's not, you're not physically traveling faster than light. It's instantaneous because of quantum entanglement. And then later on, we'll be able to work out some of the problems with quantum entanglement, and it'll become quantum teleportation that we're using back and forth to communicate. And we'll be able to communicate across the cosmos, which will really make things very, very interesting because wormholes can be opened anywhere in time and space. So there've really become some very interesting things or future possibilities that were closed before because general relativity states that you can't go faster than the speed of light, which is true. And there's also the Heisenberg's uncertainty principle and you have probability. All those three things were making it very difficult to move forward. However, by doing what I said, by regulating them and being able to measure the deformation of the fractal energy field, we're really opening up the ability to delve into some pretty fantastic possibilities. Again, these are all just possibilities. It's all theory right now. Retail is another big area, again, where we can talk, we're working at food and beverage industry, nutritional diets. There's all kinds of things where we can get into different types of food genetics. The construction, again, energy efficient building design, optimization. There's a lot of things that go on with this. This is a really big thing is going to be the materials. We're going to be able to develop materials that have characteristics that can withstand these large changes in the weather that we have, and that are able to last much, much longer than the type of materials that we have now, and can also generate energy themselves. So I think there's going to be some really big advancements due to this equation in that space as far with quantum materials. IT. This is another huge thing too. This is what the militaries are going to be interested in, is cyber defense. Because, as I explained before, when you are able to isolate an area of deformation within an energy field, you can create a quantum cryptography, which is impenetrable. There would be no way for any type of normal hacking or even a quantum hacking. I don't know how would somebody even do that, but and it also has the ability to be instantaneous. So those types of things, I think, are the biggest things that the governments and the militaries are really kind of interested in, is that cybersecurity. What this will do, which I think is a side effect of this, is that once that cybersecurity, that quantum cybersecurity is in place, that can be applied to the blockchain. And the problem with the blockchain is the visibility. That's why there's these big banks and stuff are not going into blockchain right now. They're not going to crypto. However, once it's being more secure than their traditional systems are, there'll be a major adoption to crypto by the banks. And what that'll end up doing is then paving the way for a single monetary system that's quantum based, that we can then potentially have a universal basic income. But we'll need this in order to pool the resources of all the countries in order to be able to generate enough power to stabilize a wormhole, if we're really going to get to this point. So there's some things that go into that as well too. But it's very interesting. It's fascinating. Take some things in from science fiction as well, but it's not. There are mathematical reasons behind all of these. We've got them all worked out. Hospitality, tourism planning. Basically, this framework can be applied to any complex system, and it would give you, insights because of the closed loop of the information, where you're having the macro inform the other. Social impact, again, we'll be able to take a look at different ways that we can get resources allocated. I think there's a lot of different ideas that are going to come up. Aerospace, again, this is an area where we've had some interest from some of the large manufacturers of these types of things. Automotive is another way. Insurance, I'm kind of moving through these quickly. I don't want to take up too much time. Governing, that's another thing too, as far as policy decision. It can aid in that aspect, which is something that's important to Microsoft and Bing, and how they're going to have AI decision making across these large organizations. Pharmaceuticals, they're picking up on this real quick by being able to manipulate quantum they're going to be able to come up with all kinds of new drugs. Renewable energy is another big area that we're going to. Sports and fitness, and e-commerce. I've got a group that's working on that. And this is where I wanted to get to. This shows you the platform that we're building out. And this will be, like licensed to an academic institution, and then anybody at that institution would be able to use it for whatever purposes they need to, and that would protect their intellectual property by, being able to use it that way. It's scalable. It's going to be very, it can be used not only through academics, but it will be used, commercially. And because of the fractal framework, the fractal geometry framework, it really creates a powerful simulation, and we can simulate extreme conditions through this area, which are, I think, going to be very helpful towards the advancing materials as well. And then this is my contact information of where we're at. So we're just getting started, working with the National Science Foundation, America's Seed Fund, and some of those other types of accelerator groups as well too. But I'm hopeful that this will be something that the intelligent people here can bring back to their respective companies and say, hey, this is something that we should maybe take a look at, and you may be surprised. So, and I would say that's all